Let's use K as our constant of proportionality to write the equation for each of the following statements. For the first statement, A, we're going to write an equation for the amount of sales tax on the purchase of a new car. And we're told that the sales tax is directly proportional to the cost of the car. Okay, don't forget, in each one of these, we're going to be using K as our constant of proportionality. Let's do the answer. We'll leave a space for the answer. We'll go down to part B. Find the slopes of two perpendicular lines. That's my symbol for perpendicular. The slopes would be identified as M sub 1 and M sub 2 that are inversely proportional to one another. Find the slope of two perpendicular lines that are inversely proportional to one another. And then we go down to C. We're going to write an equation for the volume of grain in a grain silo. It's varying jointly as the height and the square of the radius of the base. Varying jointly as the height of the silo and the square of the radius of the base of the silo. And finally, let's find an equation to represent D. W varies directly as R and P, and it varies inversely as the cube of T. Okay, let's go back and write equations for each of these. First, the amount of sales tax on the purchase of a new car. Let T be the tax, C be the cost. It's directly proportional to the cost, so it's T equals proportionality constant K times the cost C. Next, we have the slope of two perpendicular lines, M1 and M2, being inversely proportional to one another. So it's the constant K divided by, it's the first one, M sub 1, is equal to the inverse 1 over M2 times the constant K. So it's M1, the slope of the first line, equals K over M2, because M1 is inversely proportional to M2. And of course, our constant of proportionality is the K again. Next, we have the volume of grain in a silo that's varying jointly as the height and square of the radius of the base. Jointly just means we're going to multiply those two variables together with a constant K in the front. So it's K times the height A times the square of the radius of the base. Finally, we've got the W varies directly as R and P. So that part looks just like the one we just did, part C. But it varies also inversely as the cube of T. So we're going to have a denominator with T cubed in it. So we have W, whatever that value is, equals the constant K times R times P. That's the joint proportionality. And then the inverse proportionality is T cubed in the denominator. So those are just examples of how you can take statements of proportionality and express them as equations.